So my talk is key challenges for hybridizing gallium nitride micro LEDs and CMOS circuits. So the outline is why do we address this question actually, and we will then describe several hybridization technologies and mentioning key challenges and potential solutions or real solutions about these challenges. So to begin with, why are we talking about hybridizing? In fact, as you know, micro LEDs are very interesting, like tiny, bright, efficient, reliable, and so on. However, they need current, and even more, they need special driving and dressing, special challenging, complex circuits, etc., etc. So in most cases, it is interesting to have, or we don't have the choice, but combining these micro LEDs with CMOS circuits is necessary. In particular, in two cases. On the left, we have the TVs, and as you know, some products are now coming from Sony, etc., and most of them use actually CMOS circuit, but driven with LED, but they are separated. You know, they are placed at different places and then connected afterwards. Another case where we use CMOS is actually the case where CMOS and micro LED array are connected at scale 1, and this is actually the case in micro displays and so on. And this is actually what we are going to talk in this case today. So you can see here tree where we can summarize all the approach. The straightforward approach to couple a micro LED array and CMOS integration is to use what we call hybridization, using bumps and so on. We fabricate separately the two parts. We couple them using additional metal parts. Okay. The other ways are what we could call monolithic integration, where we can use the same approach of fabricating separately the two parts, but to couple them without these metallical parts. This is what we call hybrid bonding. And finally, there is an alternative approach where we do not fabricate the micro LED, we bond directly a gallium nitride layer on top of the CMOS, and this is called the monolithic approach. So we will review briefly of these technologies and what the results and challenges. The first is a flip chip hybridization. You fabricate separately, and then you need to make this special connection, both mechanical and electrical. So this exists for many years. It is called the flip chip, using most of the time indium bumps. This was actually made by the first demo in the what is known to my knowledge, the first demo of actual micro LED displays was made by Texas University at a pixel pitch of 15. So 15 was nice, actually, very nice, but it is limited due to the use of these bumps. And actually, for display, micro display, we need smaller. Why it is limited? Because of the technology, of the temperature, and so on. So we need to find a solution where we can go with smaller pitch. Actually, we have at Leti developed this solution called the microtube, where the principle is to fabricate on one side microtubes and the other side pads, and then to make a simple mechanical pressure between the two parts, room temperature, and then we can make both mechanical and electrical connections. These are scanning electron photographs of this approach applied to micro LED display. Here we have the gallium nitride array with pads, which are actually soft material. And on the other side, we have these microtubes with hard materials, very small size, and then you can see a cross section after hybridization, where with the microtube is inserted mechanically inside the microtube. So we use a special flip chip technology using this special approach. So actually, this solution works. We could show prototypes here. You can see photographs of the fabrication of the one side, namely the micro LED array. Very small pitch. On the other side, the CMOS, on top of which we deposit and pattern these microtubes. A first generation of prototypes were made with a limited resolution and actually a very simple circuit, not a CMOS, a simple silicon with some connections to drive some pixels, and the second generation with actually active matrix, higher resolution, and so on. I will show you brief results of these first prototypes made with the microtube technology. So for the first generation, just small pixels, small logos, but just to show the potential of this technology